Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve two questions from mechanics, and the questions belong to paper 9709/43 for the session May June 24. Let's read question number 1 of this paper. Two particles P and Q of masses zero point 0.2 kilo and zero point 0.5 kilo respectively are at rest on a smooth horizontal plane. Particle P is projected with a speed of 6 meter per second directly towards Q. After P and Q collide, P moves with a speed of 1 meter per second. Find the two possible speeds of Q after the collision. So, what are the two possible cases of this scenario? Let's analyze both of the cases. Suppose, let it be, suppose after the collision. Okay, after we are talking about after the collision. Before the collision, actually, there is no second option. P was moving onwards to Q, which was at rest. That's why before collision, there is no option, there is only one scenario. But after the collision there may be two cases. What are the cases? First case, after the collision, suppose this is P was moving after the collision. P was moving towards this direction, that means moving onward, as well as Q was also moving to the same direction. This is for Q. Q was also moving to the same direction. This is the first case after the collision which may happen. Okay, both of them are moving to the same direction. Okay, the second case is after collision, P might move backward. After the here was P, after the collision, P might move backward, changing its direction. It is P, whereas Q was moving to its forward direction. That means moving forward. This is for Q. This is for Q. So these are the two cases. What is the first case? After the collision, it may happen that P and Q both were moving to the same direction, because in case of velocity, direction matters. It's a vector term, vector quantity, so magnitude as well as direction are the equally factors. So the second option is after collision it may happen P moved backward whereas Q moved onward. So let's write the scenario, and we know for solving such questions we always pick up the concept of the conservation of momentum. The conservation of momentum, that means the formula is ma, mass of particle P into initial velocity of P plus mass of particle Q into initial velocity of Q is equal to mass of particle P into final velocity of P, that means after collision, plus mass of particle Q and the velocity of Q after collision. So this is what the concept of the conservation of momentum. Then we will substitute the values. What are the values? We do have mass of particle P is zero point 0.2, whereas the mass of the particle Q is 0.5. So 0.2, and initially particle P was projected at a speed of 6 meter per second. So it will be multiplied by 6 plus mass of particle Q is 0.5, which should be multiplied by 0, because we know that Q was kept, both of them were actually kept at rest. So at rest velocity is 0. Then after collision, particle P has a mass of zero point 0.2 and the velocity of P after collision was 1 meter per second. So we are considering that both P and Q are moving to the same direction. That's a symbol of both of the particles motion is same. If they both of them move to the same direction, then the symbol in front of them, each of them will be equal. So mass of particle q is 0.5 and the velocity of particle q after collision is to be obtained. So let it be written over here. Then if we calculate this, zero point 0.2 into 6, that is 1.2. So 1.2, then minus from right side, this is going to be 0, so which can be ignored. Zero point 0.2 into 1, that is 0.2, equal to zero point 0.5, 0.5 velocity into velocity of q. So our velocity of q when the particle p and q move to the same direction, velocity of q is going to be 1.5. From 1.5, if we subtract zero point 0.2, it is going to be 1.0, means 1, which is being divided by 5. So 5 2s are 10. It is going to be 2 meter per second. So this is the first velocity, and as it is positive, so q was moving onward. So this is one of the possible values. Let's decide and let's find out the velocity of q after the collision of the second case. What was the second case? They were after the collision, p was moving backward, whereas q was moving onward. So let us write that the second scenario may be the same concept of the momentum, conservation of momentum. M p into initial velocity of particle p plus mass of particle q into initial velocity of q is equal to mass of particle p into final velocity of particle p and plus mass of particle q into final velocity of q. So let us substitute the values. What are the values we have applied here? The mass of particle p was, as it was, 2.2, and it was projected towards q, means moving onward, so it must be positive 6, plus mass of particle q was zero point 0.5 and it was at rest, that's why there is no motion at all. Then mass of particle p is zero point 0.2 into final velocity. Okay, final velocity may be, as it is moving backward. Once again I am going to show you that when p was moving backward, this is the, sorry, this is the scenario. The system was, yes, the p was moving backward. Okay, if any particle changes its direction, then definitely it will be negative, because q was moving onward whereas p was moving backward, so their directions are different. And in velocity, remember, direction is one of the most important factors. So it is negative because p was moving to the other direction. Due to this difference in direction, it is going to be negative. So it's negative zero point 0.2 into, what was the velocity after collision? It was 1. So 1 into, in plus into, we will find the mass of particle q is zero point 0.5 and velocity of particle q after collision is to be obtained. So let it remain unchanged. Now how will we calculate? If we calculate, it is going to be point, so point 1.2, it is 1.2, 1.2, then plus point 2, point 2 is equal to final velocity 0.5 into final velocity of q. So our VQ is going to be, hence our VQ is going to, I mean velocity of Q is going to be 1.2 plus zero point 0.2, that is 1.4. 1.4 will be divided by zero point 0.5. 0.5. If we divide 1.4 by zero point 0.5, it is going to be 2.8 meter per second. So this is the second possible value of velocity of Q. So that's all about this solution. I think you have understood as I could have explained. Well, let's move on to the immediate next question. Question number 2 says, on the page of 3, it says a particle of mass 0.2 kg is attached to one end of a light inextensible string. The other end of the string is attached to a fixed point on a vertical wall. The particle is held in equilibrium by a force of magnitude x Newton, perpendicular to the string, with the string taut and making an angle of 30 degrees with the wall. Find the tension in the string and the value of x. As two of the values are to be obtained, so definitely there will be two simultaneous equations. Well, before solving it out, we will have to find the direction of the forces. Let us find the direction of the forces. Okay, so this is the system. Here, how can we do this? Yes, so let us draw this, the direction of this is vertical line. Okay, so this is vertical line. In this vertical line, suppose this one is our triangle. What is the other triangle? The other triangle, it is the another triangle. Okay, let me erase this unnecessary parts. Well, okay, then what will be the measure of this? And this is must be, this one is a right angle 90 degrees, so this angle is going to be how much? 60 degree. 60 degree. And this is vertically upward, and this must be horizontally upward. Okay, and what will be the measure of this angle? Size of this angle is, if this is 60, this one is middle one is 90, so it is going to be 30. It is 30 degree. 30 degree. Well, this is our scenario, and the system is in equilibrium. So for finding the missing value of tension is over here. This is our tension. Okay, tension is acting in the string. We all know that for finding the forces, magnitude of the forces or direction of the forces, we always apply the most widely used the concept of the motion law of Newton. So let's write the concept of the motion law of Newton. What is the concept of the motion law of Newton? It is, first let's resolve the forces horizontally. So horizontally it is going to be horizontal direction is, so first let's see what is the driving force. Driving force minus resistance force is our concept, equal to mass into acceleration. Mass into acceleration. Well, then what is our driving force here? Our driving force is just over there across the horizontal line, this one, which is, that is forwarding force is, x is our, in terms of this triangle, x is our hypotenuse. So x cos 30 degree Then we will find the resistance force or backward forces. Backward force is just this one. This is T cos 60 degree, T cos 60 degree, equal to, right side is mass into acceleration. As the system is held, the particle is held in equilibrium, so there is no acceleration at all. That means it's zero. So x cos 30 is equal to, we know cos 30 is equal to square root over 3 over 2. So square root over 3x over 2 minus cos 60 is half. So it is going to be t over 2 equal to 0. As we will have to form two simultaneous equations, let's isolate x first of all. If we isolate x, it is going to be root over 3x. This is uppercase x, so we will have to erase out, yes, over 2 equal to t over 2. Well, hence if we isolate our x, it is going to be t into 2. That means 2 can be dissolved from both sides. It is going to be t over square root over 3. If we dissolve this 2 and this 2, so t over 3, we may leave this as equation number 1, because we have already discussed that there will be two simultaneous equations, because two of the values are to be obtained. One is t, I mean tension, and another one is the value of x. Well, now we are going to resolve the forces vertically. So what are the forces acting on the vertical? Let me write just beside, no, just under this I think we can write. Okay, so vertical forces. Okay, we are going to resolve the forces vertically. This is about vertical forces. Let's see what are the vertical forces acting on the particle. First of all, if we consider this triangle, so it is going to be, vertical force is what? This one. This one is x sine 30. X sine 30. So we are going to write x, sorry, driving force. Let us write this. Driving force minus resistance force is equal to mass into acceleration. And driving force, we have got that x sine 30. X sine 30 degree. Let's see whether any other force is acting on the particle which is acting upward. Yes, there is another force, is this one. This one is the another vertical force acting on the particle. So this is T sine 60. T sine 60. So the next force is plus T sine 60. This was the upward force. Now let's see what is the downward force, that means force acting downward from the particle. So this is actually, this is the downward force. Okay, so downward force is nothing but the weight of the particle. So what will we write? We will write mg minus, downward force is minus mg cos, what is the angle here? Angle is 0 degree, because this is vertically perpendicularly downward, and right side is as usual 0, because there is no acceleration at all. The particle is held in equilibrium, so right side is 0. Let us calculate this. If we calculate, this is going to be x over 2 sin 30 means half, plus sin 60 means root over 3 over 2, so square root over 3 t over 2, and minus mass of the particle is, how much is the mass of the particle? Mass of the particle is given as zero point 0.2. It is zero point 0.2, so zero point 0.2 into acceleration is 10. So zero point 0.2 into 10, 2, and cos 0 means 1, so it is actually 2. Okay, now if we simplify this, let us do the simplification. Yes, If we simplify, it is going to be, can I write just below this? Let me try to write just below this. I think it's possible. Yes, here right side was 0. So if we simplify this, it is going to be x plus root over 3t minus 2 over 2 is equal to 0. Over 2 is equal to 0. So finally, what is it going to be? It is going to be, it is going to be, or or x plus x plus, this is not lowercase, this uppercase, x plus square root over 3t minus 2 is equal to 0. If we isolate x, what is it going to be? X is equal to 2 plus 2 minus square root over 3t, and this is going to be our equation number 2. Already we have discussed that there will be two simultaneous equation. This is equation number 2. Now if we resolve the forces simultaneously, then what will it be? Okay, now our, from equation 1 and 2, from equation 1 as well as and 2. In equation 1, x equal to what? This is equation 1. Equation 1 is t over square root over 3, and equation 2 was x equal to what? 2 minus square root over 3t. Well, let us do the cross multiplication. So t is equal to 2 square root over 3 minus, if we multiply square root over 3 by square root over 3, it is 3t. So on the left side, 3t plus t, that is 3t will also be positive, so it is 4t. 4t is equal to 2 square root over 3. No, this should not be. Here there is a little mistake we have made. Look at this. It should not be 2. Yes. In the second equation, look at this. It should not be 2. Rather, it should be 4. It should not be 2. It should not be 2. It should be 4, because 2 2s are 4. So let's write 4 over here. If this is 4, then in rest of the cases also it is going to be 4. It is not negative 2 at all. It is going to be 4. This is 4. So let's write 4 over here. This is 4. This is 4. Hence we will have to write 4 in the equation also. Yes, it is not 2 at all. It is going to be what? This will be 4, and this is going to be 4. Let it be written as 4. Then this is also no more 2. It is going to be 4. Let's write 4 over here. 4. Okay, so 4, 3t plus 1t, 4t is equal to definitely 4 square root over 3. 4 square root over 3. 4 square root over 3. Hence our t is going to be square root over 3. Square root over 3 means, let's find the square root over 3 in decimal form. It is 1.73. It is going to be 1.73 to so 1.73. So this is the tension acting on the string. T 1.73 Newton. This is what our answer. It is our answer. Okay. Now we will find the corresponding value of x. Okay. So x is going to be, for x, let's change the color. Hence x is equal to, x was what? X was this was the equation. From equation 1 we get x equal to t over 3. So t is actually square root of r 3, square root over 3 over 3 over 3. That means it is simply 1. Okay, if you divide square root over 3 by square root over 3, it is 1. So answer to the question number 1 is t, the value of t, magnitude of t is 1.73 Newton, whereas magnitude of x is 1 Newton. So that's all about the solution to this question. And I believe that you have understood it very well, because there is no twist and complication in this question at all. It's very easy to be practiced and learned. So fi amanillah.